In this video, we're going to solve another trig equation, and as a matter of fact, this is very, very basic, even though it looks more complex, but we're going to look at trig equations that have a little bit more substance in their angles, okay? So one thing I want to point out here is this. All of this stuff in here represents a single angle. This is like theta, okay? So what I'm telling you is essentially we have an equation here that says sine of an angle equals root 3 over 2. I already know what to do in this instance. I already have the trig function by itself. We can already go ahead and take the sine inverse of both sides, which is the same thing we're going to do over here, and then solve for the angles. It's just that we have a few more steps that are built in, okay? So number one is this: isolate the trig function. I noticed that the trig function is already isolated, okay? So what we're going to do is we're going to take the sine inverse of both sides, and I am going to actually show my work on this. So we say sine inverse of everything on the left, which is this. Sine inverse of the angle, of the sine of the angle, 2a minus 50 degrees, is equal to the sine inverse of everything on the right of this equation, which is root 3 over 2. And so what happens is these cancel out, and I'm literally left with then 2a minus 50 degrees is actually equal to the sine inverse of root 3 over 2, okay? So what we need to do is this: before we go digging any further with what these angles are, and there's more than one angle, what we're going to do is we're going to ask ourselves this question: what could I take the sine of and get root 3 over 2? So let's start with this, the reference angle. What reference angle would I have to take the sine of to get root 3 over 2? Would it be, 0, 30, 45, 60, or 90? And what I can tell you is when you take the sine of a 60-degree angle, those are the only times you get root 3 over 2 with sine. So what we're going to do is this: we're going to sketch out all possible reference angles of 60 degrees. So we say each one of these here, the way I'm kind of representing them, these are all 60-degree reference angles. And I'm going to write in all students take calculus. I wanted to know, where did sine come out to be a positive root 3 over 2? So that would either have to be in the first quadrant or it'd have to be in the second quadrant. So we say these two angles are these. We say, first of all, 60 degrees. 60 degrees. That's one angle. And then the second angle, let me get that out of there. That looks really bad. 60 degrees. We say the second angle would be 60 degrees shy of 180. That would be 120 degrees, okay? So here's what makes this problem a little bit different. We actually have to take this out and split it up into two possible cases. We say, well, 2a minus 50 degrees is equal to either 60 degrees or 2a minus 50 degrees, or the angle was equal to 120 degrees. There's also one more amendment we need to make to this right here. It said find all degree solutions to the following equations. So when they say all, they don't mean just 60 and 120. They mean also anything that's coterminal with them. So how can I find a coterminal angle to 60 degrees? Well, I could just keep adding on multiples of 360 to it, and I would land back in the same spot. So what this means is we have to write plus 360 degrees times k. Let's split these apart here. And over here we have to write plus 360 degrees times k. So these are all possible angles that could work. Now all we need to do is find out, so what is a? What would this a value have to be? So we'll just isolate a now. This is, solving an equation again. We say plus 50. I'm going to add the 50 to the 60 here because I know that those can go together. And I get this. I say 2 times a equals 50 plus 60, which is 110 degrees, plus the original 360 degrees times some integer. And then over here I'm going to add 50 also. I'm going to add 50 to both of these constants here, 50 degrees, by the way. And so we say 2a is equal to 170 degrees plus 360 degrees times some multiple of an integer. And then we say, all right, well, divide by 2. The thing that's important here is this: we have to divide everything by 2, which means on the left side here, or the right side of this left equation, a equals half of 110, so it would be 55 in that case, and then half of 360 would be 180, so plus 180 degrees times k. And then over here we're going to divide everything by 2, and we get a equals half of 170, which is 85 degrees, plus half of 360 is 180 degrees k. And so you'll notice that at least in terms of my two a values here, these have to be the same. I will promise you that. But these are the two angles that I concern myself with in this video. Cheers.